So we've kind of been building up, talked about graphical displays first for quantitative distribution. So you have histograms, dot plots, stem plots. Then we talked about describing, so we kind of touched on the surface of that on Tuesday, talking about shape, center, spread, dealing with median for center, range for spread, shape, symmetric versus skewed. And then yesterday we kind of delved a little bit farther into center, talking about mean versus median. When do we use mean? When we have a symmetric distribution, we use median if it is skewed or has outliers. So skewed or outliers, median, symmetric, mean. And then we talk about the IQR. What is the IQR? Because that's going to play an important role in today's lesson.
Inner quadrant range?
Inner quartile range. And there was a calculation. How do we calculate the interquartile range? Q3 minus Q1. So third quartile minus first quartile. Okay. So yesterday we talked about how to find the IQR. So we said arrange your list, find the median, and then quartile 1 would be the median of the lower half, quartile 3 would be the median of the upper half, right? Today we're going to talk about how to do that on the calculator, so it's going to be a little bit quicker, a little bit easier to go through these types of problems. So first thing we're going to talk about is what's called the 5-number summary. This is a summary of numbers that gives a quick look at both the center and the spread of a distribution. This will be the summary of choice when you have skewed distributions or when you have outliers in your distribution. So the 5-number summary is going to be what you choose to summarize your distribution if it's skewed or if it has any outliers. Now the 5 numbers, it's called the 5-number summary for a reason. There are 5 parts to it. So the 5 pieces that you need with your 5-number summary: the minimum, you need the lowest observation in your set. You need quartile 1. You need the median, quartile 3, and the maximum, the largest observation in your set. You need those 5 numbers when you report a 5-number summary. So looking at this, median is the choice for center. That's why we use this summary when we have skewed distributions or outliers. It also calculates the quartiles. So if we have the quartiles, what measure of spread can we calculate? IQR. So median and IQR go hand in hand. When you choose median, you choose IQR as your measure of spread, because you're going to be finding it using this 5-number summary. And then the minimum and maximum allow us to calculate what? Range. So if we wanted to know the range of the distribution, we take our max minus min and find the range. Okay? So, how to find our 5-number summary? By hand, it's just like we've been doing the entire time. Arrange your data set in order from smallest to largest. The min and the max are pretty straightforward. Find the smallest value, find the largest number. Median, quartiles, minimum, maximum. So min and max should be easy to find right away. Median and quartiles may require a little bit of searching. So you find your median first, then find the median of the lower half for quartile 1, find the median of the upper half for quartile 3. Now in your calculators, to find the 5-number summary, so go ahead and get your calculators out. Let's go through this process. Something to mention at this point, we have our first quiz next Wednesday, is the way it's looking right now. As far as working out the problems, there will be problems where you have to calculate like 5-number summaries, mean, standard deviations, things like that. If you don't have a calculator by then, you will be doing all of that by hand, which takes quite a bit of time. So if you don't have a calculator by next Wednesday, you're going to be doing a lot of things by hand. You can still do all the problems. It's just going to take you a lot longer than the people who have a calculator. So make sure you're getting on top of that here in the next week. So if I want to find this 5-number summary using the calculator, the first step is going to be enter the data into your list. So how do we get to our lists? Stat, enter. Right? So just stat, enter. It should take you right to your list. If you have a different calculator than the 83 or the 84, whatever process you used yesterday is going to be what you need to do.
So since it has the stuff from yesterday, if you bring it to your list, will it just like forget the other information?
Yes. Yep. So if you already have something in list 1, to get rid of it, just scroll up once, just highlight the L1, and hit the delete key or clear key. Actually, hit the clear key, I think, is probably the better choice. And then hit down.
Clear one.
Clear doesn't clear it?
Go down.
Hit down once you hit clear. If you scroll down after clear, I think it'll take it out. So, once you have that, go ahead and enter the points into the list. If you ever get into your lists and you notice that like L1 is missing for whatever reason, like somehow you managed to delete that list, make sure you let me know. There's a couple different ways we can go about getting it back usually, so that you have that, because otherwise it's going to screw up when you go to do the different functions. The calculator's still going to default to list 1, but you're entering into like list 2 or 3 or whatever else is there. So always be kind of aware of that when you go in there. All right, so we're going to have their list completed. So once we have our list, when we want the 5-number summary, we're going to go back into that stat menu. Now we want to calculate, so go over to the calculate menu, so scroll right. And then you can actually choose the exact same thing we did yesterday for mean. Choose the 1-bar stats. So if you hit 1-bar stats, hit enter. Some of you will get the little menu. Just make sure it says list 1. Don't put anything in for frequency and then hit calculate. Otherwise, just hit enter. And right away you should see X bar, right? So from that screen, if you scroll down all the way, so use the arrow key, scroll all the way to the bottom, what do you see? What's that?
The last 5 or those 5?
Yep. So the last 5 entries is your 5-number summary. So when you go to that screen, when you do the 1-bar stats, and you scroll all the way down, it's going to give you your 5-number summary. So it gives you your minimum, quartile 1, median, quartile 3, maximum. Okay? So much faster than taking an entire set, rearranging them, and then finding all the pieces. Just plug it in your calculator, find it that way. So when they ask you to do that in the homework or on a quiz or test, just use your calculator, get that 5-number summary real quick. We okay with that? Now when we write our 5-number summary, we're not actually going to list out the minimum is this, the maximum is this, the quartile 1 is this, and so on. When you write your 5-number summary, you can just write the 5 numbers. Now when you do that, just make sure you put spaces between each of the numbers so people can clearly see which numbers are being defined here. So all you're doing is just listing the 5 numbers out. So minimum of 9, then 27, 39, 50.5, and 70. And they should know that those numbers go in order of minimum first, quartile 1, median, quartile 3, and then maximum. So when you report your 5-number summary, this is the way I want you to do it. Is just list the 5 numbers, keep enough space in between them that you can tell they're completely separate entries. We okay with that? All right. Boxplots. Boxplots are a 4th type of quantitative display. So when you're dealing with quantitative variables, we have histograms, we have stem plots, we have dot plots. Now we're going to introduce box plots, or what you'll sometimes see them referred to as box and whisker plots. Have you guys seen box plots before? A little bit, so you kind of are familiar with them. Now, have you had to create them or just kind of see them and analyze them? A little of both. Okay? So some of you might be a little familiar with this, some of you maybe not so much. When you calculate it, or when you create a box plot, you are basically just graphing the 5-number summary. You're taking those 5 numbers, putting them into a display, and connecting them with a box and some lines. So what you're doing here, if you're given a set of data, the first thing you'd have to do is calculate your 5-number summary. So you need your min, max, quartile 1, quartile 3, and median. Okay? So the first step is find these pieces. Okay? Now, one of the things, and we talked yesterday about finding outliers, using the upper fence and the lower fence. So one of the things to keep in mind, we know that this 85 was considered an outlier by that 1.5 IQR rule. We treat outliers differently than we treat the rest of the graph. So when you create a box plot, once you have your 5-number summary, you have to calculate your upper and lower fence. Every box plot will require that upper and lower fence. Once you have those fences calculated, then you need to actually determine if you have any outliers. If you don't have any outliers, then you just create the box plot like normal. If you do have outliers, you need to leave them out of the conversation until the very end. You ignore them completely until you have everything else completely done. Okay? But you have to calculate those fences for every single box plot you create, and then you have to note any outliers that may appear in the data. So, in this case, we don't have any outliers in the bottom, we only have the one outlier up top. So when I go to make my box plot, the first thing we need is an axis. So this is a lot like a dot plot in that we only need the one axis, so in this case the horizontal. What we need to make sure on our axis is that we scale it so that our minimum and maximum values are accounted for. So here, I just made mine from 0 to 90. So that accounts for the 5 at the bottom and the 85 up top. We do need to include the outliers in the graph, but they're going to come in at the very end. So we do need to make sure we account for those on that number line. Okay? So, once we're here, the first thing you can do is plot your quartiles and your median. The way we do that is just with 3 vertical lines. So where quartile 1 would be located at 15, we create a vertical line. Where the median is located at 22.5, vertical line. Quartile 3 at 42.5, vertical line. And we just make them all pretty much the same length. So you're just going to line them up where they go over top. And create a box. So here's where the box plot of the box plot comes from. So 15 for quartile 1, 22.5 for median, 42.5 for quartile 3. Create a box that goes around the quartiles. Now what this box is telling us is where that middle 50% of our distribution is. There's our IQR, right in the box here. Okay? So once we have our box created, the next thing we're going to do is extend lines out to our extreme values. So our minimum and our maximum if we're able to. So on the left side, when we go to the minimum, we didn't have any outliers down here. So we go to 5 and stop our line. So we're going to reach out from the box to our minimum value of 5. Now a lot of times, and you'll see on my answer key, the book will sometimes just draw the line and leave it like that. I will usually put like a line on it just to kind of match up with the other vertical lines we created for the median and stuff.
Like the height or whatever the box is on matter?
Not really, just make sure you keep it consistent throughout. So yeah, it doesn't matter how wide you make it as long as it's readable is the main thing. Okay, so we're there. Now, when we go to our upper end, 85 was an outlier. So here's where we basically ignore 85. We are not going to extend to outliers. We only want to extend to values that are still considered okay. So what's the largest value in our set that we consider to be okay still? 65. So when I extend my line to the upper side, I stop at 65. That's my point where I'm going to cut myself off. So again, you can just leave it as the line there, or you can create the vertical line at the end and know a little bit easier that's the stopping point. Everyone with me so far? Okay. Once I have my main body of my box plot created, now we can do what we need to with the outliers. Outliers just simply receive a dot over their location on the axis. So in this case, when we want to add the 85 in, we just put a dot over the 85 and line it up with the rest of the box plot. Keep everything in a line. So we know all of this goes together here. So here's the main portion of our box plot, where we have the box and what they sometimes call the whiskers. And then we have our outlier way out at 85 that just gets the dot. If we have multiple outliers, we just put a dot for each one. So let's say we had another value at like 92, we put another dot at 92. So you put another dot for each outlier that's in the data. We okay with that? Now, one thing to note here, we used our upper and lower fence to determine outliers. So, do you see the upper and lower fence on the graph? Did I plot where those fences occurred? No. We never plot the upper and lower fence on our display. The only things we want displayed are the actual data points. Okay? So don't put the fences, don't draw those into your figure. You know where they're going to be because you've calculated them beforehand. You know which points are outliers, which points are not. So when you extend in either direction, extend down as far as the values are acceptable. If you have values outside the lower fence, you do not extend to those. Those get dots. Extend to the highest values above that are acceptable. As soon as you hit the fence, now they get dots. Okay? But notice the extension here. We don't extend to the fence. The fence, if you remember yesterday, was like 83.25. We don't extend there. We want the data to be shown in the picture. So we stop at the highest value inside the fence. Does that make sense? Okay? So, to get some practice with this and to introduce a second idea involving box plots, we're going to run through an example together here. So from start to finish, here's the data. We're going to calculate the 5-number summary. We're going to calculate the fences. We're going to create the box plots. Now, what we're actually going to do here is create what we call parallel box plots. When you see that term parallel box plots, all they're asking you to do is take multiple sets of data and graph them on the same axis. So you're going to create one axis, number it from the minimum to the maximum of all the sets of data, and you're going to put the box plots on the same axis. You're just going to stack them on top of each other. Hence the parallel. They're going to run the same direction, one on top of the other. Now we're going to do a parallel box plot where we're only doing 2 sets of data. But you can have parallel box plots for any number of sets. So you could have anywhere up to like 20 box plots just next to each other and try to compare. So it just kind of depends on what you run into. So we're going to create parallel box plots here. So the first thing, go ahead and type in the information for Franklin into list 1. And then if you want to, if you get done with that, type in the information for Jackson. You can do that into list 2.
Do
You have this here on you?
Oh, like, yeah.
Yeah, that's why you just, well, you can do, if you get a second. So you don't have to. Second memory, second plus.
Oh,
It should, but no, we're not there.
I don't know about like.
You, I already do.
Oh.
You got this one.
Oh.
You should have this one.
Yeah.
So if you go.
Yeah. The one, the blue one. That one's still good. It's still good. It's still not. I have like
Be aware that if you do that, like if you have anything else in your calculator that you might want to. Yeah. Okay, so list 1 for Franklin, list 2 for Jackson. Yeah, once you're completely done entering both lists, let me see it. I gotta see something here.
It's so funny that starts something really good. Like, I could just see you doing that. Somebody else is having like a one of those. I have a huge girl. I got a girl. Like the big. Just like helping one. Sharp ones from Alec. Just bring it out. Yeah.
Okay, so now if you have the two lists entered, to find the 5-number summaries, you need to actually do them separately. So you're going to do 1 bar stats for list 1, and then 1 bar stats for list 2. Now the other way to do this is to enter list 1, get the 5-number summary, delete it out, enter Jackson into list 1, find the 1 bar stats, and go that way. But if you have them both in there, you can do it all a little bit easier without having to go back and do all the extra work there. So first thing, do your 1 bar stats for list 1. And so for Franklin, what's our 5-number summary?
25, 30, 41, 54, 60.
Start again.
25, 30, 41, 54, 60.
I'm to 30.
41, 54.
I didn't get that.
Uh-oh.
I got 29, 32.5,
Yeah, 41.
41, 54, 60.
Okay, so always make sure before you start doing calculations, run through again, make sure everything's entered correctly. Okay, so you guys got 29,
32.5,
32.5,
41,
41,
54, and 60.
like that. Everybody agree with that? Okay, so here's our 5-number summary for Franklin. All right, now we're going to do the same thing for Jackson. So this time, when you want to do your 5-number summary, you're going to go back to 1 bar stats. So you're going to go to stat, over to calculate. You're going to choose 1 bar stats. Now for those of you that get a menu drop down, it's going to ask what list you want to use. So right now it should say list 1. If you want to change that, if you hit second stat, it should bring up a list of the lists, correct? So you would just go down and choose list 2 and hit enter. And then go through your menu like normal. Nothing for frequency, hit calculate. If you don't get the menu, if all you get is, it says 1 bar stats on your screen, right after that, you need to tell it to put list 2, because it's going to do list 1 automatically. So when you get the 1-bar stats up on your screen, go to second stat, choose list 2, and then hit enter. So that's going to default it to list 2 for this attempt. All right, so what do we get for Jackson?
15, 21, 38.5, 59, and 78.
Okay with those? Okay, so next thing, once we have our 5-number summary, we need to check for outliers, which means we need to calculate our upper and lower fence. So for Franklin, our upper fence would be quartile 3, 54, plus 1.5 times, what's our IQR? How do we calculate IQR? Quartile 3 minus quartile 1. So we take 54 minus 32.5. So 21.5. So we take 1.5 times 21.5. So in your calculators, plug that in real quick. 54 plus 1.5 times 21.5. What is it? 86.25. Everyone agree with that? Okay. Lower fence starts at quartile 1. So quartile 1 was 32.5 minus 1.5 times our IQR. And we get 8.75. 0.25. Last time I trusted you, Ben. 0.25. Everyone else agree with that? All right. So, based on that, do we have any outliers in our Franklin distribution? No. There's nothing below 0.25, and there's nothing above 86.25. So there's no outliers that we need to concern ourselves with. So then the next thing is we go to Jackson, and we do the same process. So we got to calculate our upper fence. Now what's our IQR for Jackson? So 59 minus 21, 38. So for our upper fence, we're going to take our quartile 3 plus 1.5 times 38. $116. And then our lower fence is going to be quartile 1, so 21, minus 1.5 times 38. Negative 36. So any outliers in this one? Nope. So our fences are well above all of our data points. So the next thing we want to do is just create our display. So create our box plots. So we need an axis, which we can label what? What's the variable we were measuring here? Average 10. Okay, and this is in degrees Fahrenheit. So always put units if they have units in the problem. What do we have to range from? What's the lowest overall value? 15, so we need to make sure, because these are both going to go on the same scale, so we need to go from 15 up to 78 basically, right? So we could go from like 10 to 80, and we'd be able to account for everything, right? So if we go by tens, and when you do this, try to stay as evenly spaced as possible, right? Try to keep them as evenly spaced as you can. So we got 10, 20, 30, 40, up to 80. and now we plot. So when you're going to do multiple graphs or multiple box plots, you want to kind of off to the side at least label. So we're going to put Franklin down here on the bottom, and we'll put Jackson up above here. So just give a quick label as to which box plot is which, and then just plot your points. So we don't have any outliers to worry about, so we can put everything in that we want. So minimum at 29. We have our first quartile at 32.5, 41 for the median, 54 for quartile 3, and then 60 for our max. So we box up our quartiles and medians, and just extend the line out to the min and max. Again, as you're making these, make sure those vertical lines you create are about the same height, keep things consistent. So there's Franklin's box plot. Now we're going to do the same thing with Jackson, so no outliers again to concern ourselves with. So we go from 15 for our min, 21 for quartile 1, 38.5 for the median, 59 for quartile 3, and 78 for the max. And again, when you're doing this one, make sure you keep these bars about the same as what you did for the first one. You don't want one box plot being really wide and the other one being really narrow, because now you're bringing area into the equation, and we only want magnitudes to be the comparison. So here are my two box plots. Now you'd be able to kind of make some comments as to what's going on with these distributions that they asked you to compare. So they both seem to be fairly symmetric. Yeah, the median falls pretty close to right in the middle between the quartiles is a way to decide that. If the median falls really close to one quartile or the other, that means it's going to be skewed one direction or the other. Otherwise, it seems pretty symmetric for both. Their centers appear to be very close, right? So 38.5 and 39, so their centers, the medians are pretty close to each other. But what do we notice is a big difference between the two? The mins and maxes are quite a bit different. What do we notice about the entire range of values for Jackson versus Franklin? How does the spread compare? Which one has higher varying temperatures? Jackson. Jackson's temperatures vary a lot more than Franklin's do. Franklin's stay pretty consistent, right? Versus Jackson's, which go all the way from 15 up to 78, so that's much more variable as far as average temperatures are concerned. Okay, so things to kind of note here, their shapes are similar, their centers are pretty similar, but their spreads are drastically different. The middle 50% of Jackson covers or encompasses almost the entire range of Franklin's. So there's a much wider array of temperatures in Jackson than there are in Franklin. Are we okay with that? So those are the kinds of things that you're going to be expected to do with box plots and 5-number summaries and things like that. Create the 5-number summary, use it to find the fences, create a box plot. If they have you do multiple box plots, be able to compare. So comment on shape, center, spread, kind of like we've been working on the past week or so. Okay. All right. That's it. So your assignments. I know I might have gone a little long with this one, but I'm hoping you guys can forgive me if I gave too many here. These boil down to basically just taking a set and creating a box plot and then making a couple comments on it. If you have homework done from yesterday, I'll take that if you want to turn it in. Remember, if you have any missing assignments, you know you haven't turned anything in, it's a good idea to get those assignments in ASAP so you're able to use notes on your quizzes. Again, make sure you're utilizing the answer key to check your work, make sure what you're doing is correct.
You're still listening.
We still do that.
No, it's good. I guess.